Hey guys, it's Miss Motzi, and I'm going to walk you through the notes on the moon. So, there are some different theories on the origin of the moon, but we didn't talk about them too much in class, and you shouldn't expect to see them on the test. The most widely accepted theory proposes that the moon was formed about 4.5 billion years ago as a result of a collision between Earth and a planet sized object. The moon has a lot of different craters, and those craters are these like circular holes right here, and they're caused by different asteroids and meteoroids crashing into the moon. Like the solar system was a really chaotic place when it first formed 4.6 billion years ago. We actually always see the same side of the moon from Earth because the moon's rotation time and revolution time are almost the same. They're like about 28 days or 4 weeks or about a month. Now I'm going to skip through some of these slides because I want to talk to you about the moon's motions and moon phases. I don't want to focus too much on the rocks on the moon right now. So you can skip through all of this. And skip over to the moon's motions. So it takes the moon about 28 days to orbit Earth, or to revolve around Earth, or go around Earth. And let's take a look at this picture here. So on the left-hand side, this is a top view. So you can see like Earth is here, this green ball, and Earth is orbiting or revolving around the sun. You can see this is an oval or elliptical shaped orbit. It's not a circular orbit. And then you see the moon right here. The moon is also orbiting or revolving around Earth as Earth is going around the sun. On the right-hand side, you see a side view of those orbits. And you can see that Earth's orbital plane and the moon's orbital plane are not completely in line. The moon's orbital plane is tilted about 5 degrees, and that's why we don't have lunar eclipses or solar eclipses every single month. I'm going to skip this slide for today. We see the moon only because it reflects sunlight. The moon doesn't make any of its own light. It doesn't emit any of its own light. It's just a rock in space, and we're seeing sunlight being reflected off of the surface of the moon. Always 50% of the moon is lit up, but we might not necessarily see all of that 50% that's lit up because of where the moon is in its orbit. So we talked a little bit about waxing and waning. Waxing is like when you wax a car and it increases in brightness. That's when it goes from new moon to full moon. So some people are remembering this light on the right. So when you go from new moon to full moon, the light starts on the right-hand side of the moon from what we can see here on Earth. Waning is what happens when you're like tired at the end of the day, your energy starts to wane. Or in the case of the moon, it decreases in light. So waning is when it goes from full moon over to new moon. So it's going from total brightness that we can see, and the dark starts coming in on the right hand side. So this picture here is of a new moon, totally dark. And then after that, you have waxing crescent. About a week after the new moon, you have a first quarter moon. And after that, you have the waxing gibbous. And then finally, 2 weeks after the new moon, you have full moon. This is total brightness. We can see all of it from Earth. After that, the dark is going to start coming from the right-hand side. You have the waning gibbous, third quarter, and then waning crescent. So the whole process takes about 4 weeks. There are 2 types of eclipses. There are lunar eclipses and solar eclipses. A lunar eclipse happens when we're at full moon phase. So this is full moon phase here because the sunshine is making its way around Earth, bouncing off the moon. Then from Earth, we see all of the light So that's full moon phase. But when our orbital planes are in total alignment, that's going to be a lunar eclipse. And a lunar eclipse looks like this right here. It looks like a full moon that's red, rusty red in color. Lunar eclipses occur at full moon phase, like I said. The orbital planes have to line up, and it's a dusky red color. Lunar eclipses are safe to watch. They occur on average about once a year, and they can last for up to 2 hours. Now, solar eclipses are a little bit of a different story. This is when the moon comes in between the sun and the earth. They only occur at new moon phase, and the earth's orbit and the moon's orbit have to line up. Here's a picture of a total solar eclipse here in the middle, and you can see the moon is totally black because that's new moon phase. The part of the moon, the 50% of the moon that's lit up, is the 50% that we cannot see from Earth. And then all around the moon, you see this light here, it's like a halo. That's called the corona of the sun. So the new moon is just totally blocking out the disk of the sun. So again, this is happening at full moon phase, which is pictured here. You have the moon in between the earth and the sun. Partial solar eclipses happen at least once a year, but total solar eclipses are much more rare. Solar eclipses are not safe to look at. You should never look directly at the sun without special glasses, and solar eclipses only last about 7.5 minutes. The Apollo moon missions landed the first man on the moon. They lasted from 1961 to 1975, and the first man was Neil Armstrong on the moon, and that happened on July 20th, 1969. Another thing to note about moons is that moons cause the tides. So tides are the periodic rise and fall of the ocean level, and it's caused by the gravitational pull of the sun and the moon. So we get the strongest tides when we're at a new moon or a full moon phase, when the earth, the moon, and the sun are in total alignment. We get the weakest tides at first quarter and third quarter, and that's because the sun's gravitational pull and the moon's gravitational pull are sort of canceling each other out because they're pulling in different directions. All right, that's it for moon notes. I will catch you up with planets in a second.